Hello and welcome to Integrate with Identity Management Systems and Manage Application Configuration Data. I'm Andrew Conniff, a technical trainer at Microsoft, and in this video, we will continue talking about deployment patterns, and now we're going to focus a little bit on security, so let's get started. Integrating GitHub with single sign-on means connecting our organization's identity provider like Microsoft's Entra ID, Okta, or Active Directory Federation services directly to GitHub. This setup allows users to access GitHub using their existing work credentials and streamlines the login process and improves security. Both the SAML or SAML and the SCIM protocols are supported depending on the provider, making it flexible for different enterprise environments. Single sign-on also enables compliance with organizational standards, making it easier to manage permissions and audit activity across GitHub repositories. For technical teams, it means less hassle with passwords and more time focusing on development. GitHub uses a system of roles and permissions to help organizations manage who can access and control their repositories. For personal accounts, there are two main roles: owners, who have full control and can invite collaborators, and collaborators, who can be granted read or write access to specific repositories. When working within organizations, GitHub expands these roles to include organizational owners, members, moderators, billing managers, security managers, app managers, and outside collaborators. In enterprise organizations, even more roles exist, such as enterprise owners with full control, enterprise members included in an owned organization, and guest collaborators with restricted access. Azure DevOps uses a robust system of permissions and security groups to help organizations control who can access, modify, and manage resources within their projects. There are different levels of groups. Some operate in the organizational level, like project collection administrators and build administrators, while others work on the project level, such as contributors, project administrators, and readers. These groups make it easy to delegate responsibilities, automate access management, and ensure only authorized users can perform sensitive actions. So by planning and using Microsoft Entra ID groups, teams can further streamline access and automate group associations, making management more efficient. Workload identities in Azure allow applications and services to securely access resources without relying on credentials. So instead of using a username and password, you register an application with Microsoft Entra ID, formerly known as Active Directory, and create a client secret and grant the necessary permissions. When the application needs to connect, it presents its tenant ID, application ID, and client secret, making the process secure and automated. This approach is especially useful for automating tasks, integrating services, and managing permissions at scale. By using workload identities, organizations can avoid the risk of hard-coded credentials and simplify the access management. It also ensures that only authorized applications interact with sensitive data. It's a best practice for modern cloud environments, supporting secure connections between apps, APIs, and Azure services. Managed identities in Azure are a secure way for applications and services to access resources without needing to manage credentials like passwords or secrets. And there are two types: the system assigned, where the identity is tied directly to the specific service, and user assigned, where you create a managed identity and then you assign it to one or more services. This approach removes the hassle and risk of manually handling credentials and makes it easier for developers and administrators to keep systems secure. Now let's talk a little bit about application configuration data. Application configuration data is typically stored in files that define how our software behaves in different environments. While this approach is common, it can create challenges. Making changes often requires downtime and extra administrative effort. When multiple instances of an application are running, keeping local configurations up to date becomes even more difficult, increasing the risk of errors and inconsistencies. That's why it's important to rethink how we manage and secure configuration information. Modern best practices encourage centralized configuration management and implementing robust security controls. This not only streamlines updates and reduces downtime, but helps protect sensitive data from unauthorized access. Application security benefits from clearly separating the responsibilities and permissions around configuration data. There are typically four main roles: the configuration custodian, who generates and maintains configuration values; the configuration consumer, who defines the schema and uses these values in code; and the configuration store, which is the underlying system where the configuration data is kept; and the secret store, a dedicated place for sensitive information like passwords and API keys. This separation helps teams manage configurations more securely and efficiently, ensuring that each aspect is handled by the right people or systems. By dividing these responsibilities, organizations can improve security, reduce errors, and streamline updates. Developers can focus on consuming configuration values without worrying about how they're stored or maintained, while administrators can ensure that sensitive secrets are protected in specialized stores. Modern applications often need to manage configuration data efficiently and securely, especially when running across multiple environments or instances. The external configuration store pattern solves this by storing configuration information outside the application in a dedicated external storage system. This setup allows applications to quickly read and update configuration values through a standardized interface, making it much easier to manage changes without redeploying or restarting the application. Azure DevOps secure files are special files like certificates or credentials that you can upload and manage securely within your DevOps pipelines. These files are stored in the library section and access is tightly controlled, so only authorized users can use them in their workflows. When you need to use a secure file in a YAML pipeline, you can download it with the Download Secure File at one task, ensuring sensitive information is handled safely and efficiently. Azure App Configuration is a cloud service designed to help teams manage application settings and feature flags in one central place. This is especially useful for distributed applications, like those built with microservices or serverless architecture, where keeping configurations consistent across environments and geographies can be challenging. With Azure App Configuration, you can dynamically change application settings without needing to redeploy or restart our applications, making it much easier to adapt to new environments or fix issues on the fly. One of the standout benefits is the ability to control feature availability in real time. This means you can roll out new features to specific users or regions, test changes safely, and respond quickly to feedback. By centralizing this configuration management, Azure App Configuration streamlines operations, reduces downtime, and empowers teams to deliver updates confidently and securely. It's a must-have tool for organizations aiming for agility and reliability in their DevOps practice. Azure App Configuration stores settings as key value pairs, where both the key and the value are Unicode strings. This flexible approach allows you to organize configuration data using hierarchical naming conventions, making it easier to manage settings for different services, environments, or regions. For example, you might have keys like appname, /service1, /API endpoints, or appname, /region1, /DB endpoint, and use labels to distinguish values for testing, staging, or production environments. Azure App Configuration isn't just for storing settings, it's also a central hub for managing feature flags. As discussed earlier, feature flags are simple switches that let you turn on application features without redeploying your code. Each flag has a name and a set of filters which define when and for whom the feature should be enabled. For example, you might enable a new feature for only 50% of users by setting a percentage filter, or target specific groups for early access. This flexible system can also support using appsettings.json as a source, making it easy to integrate with existing .NET applications. Azure Key Vault is a centralized cloud service for managing our organization's secrets, keys, and certificates. By integrating Azure Key Vault with Azure pipelines, we can securely store sensitive information like connection strings, API keys, and certificates, and access them directly within the automated deployment workflows. This integration ensures that secrets are never hard-coded or exposed in source code, dramatically improving security and compliance for DevOps processes. This approach simplifies administration and enhances protection of critical assets. Azure Key Vault allows us to monitor access, manage usage, and integrate with other Azure services, making it easier to centralize secret management and maintain control over who can access sensitive data. Applications often rely on sensitive information like secrets, tokens, and certificates to function securely. Azure Key Vault provides that centralized solution for storing and managing those critical assets, ensuring that the secrets and keys are kept safe from unauthorized access. By centralizing secret management, we can securely store credentials, monitor who accesses them, and simplify administration across different applications and services. The benefits of using Key Vault include enhanced security, easier integration with other Azure services, and streamlined management of application secrets. Security administration can monitor usage and access while developers can focus on building features without worrying about exposing sensitive data. In modern DevOps practices, the inner loop and outer loop describe how development and operations teams collaborate, build, test, and deploy software. The inner loop is all about the developer's daily workflow, writing code, debugging, validating, and running applications locally. Developers consume configuration published by the outer loop, allowing them to iterate quickly and focus on improving their solutions without worrying about the broader operational concerns. The outer loop, on the other hand, is managed by operations engineers who govern configuration management and push changes to the production environments. This loop ensures that the configuration updates are securely handled, often using tools like Azure Key Vault. By separating these responsibilities, organizations streamline development, maintain security, and enable faster, more reliable deployments. This approach empowers teams to innovate rapidly while keeping production systems stable and secure. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch the other videos in this series or search out your next favorite topic on Microsoft Learn at aka.ms/learn.